Good evening, everyone. If you are joining me because you are absent in class today, then start the video here. If you are joining me on Thursday and you are in class on Wednesday, we are going to pick up on this page here. So I'm going to go ahead and draw a big star on it. I'm going to go back to the beginning of this video, and you guys that were in class today, just fast forward the video till you see the big star, and then you can start there. Everybody else, we're going to travel back in time, and we are working on 1.11, which is perpendicular bisectors. In the Schoology lesson, I included a short little animation on what it should look like. If you're feeling confident and you don't want to look at the animation first, go ahead and take out your not your patty paper, but your compass and your protractor, and go ahead and do these 5 steps using this segment on the next page. If, however, you get a little stuck, watch that video. I'm going to go ahead and try to create a perpendicular bisector without a compass, which means it's not going to be perfect, and yours will be. So let's see. I don't know why I try to do this all the time, but it never works quite out the way that I want it to. This is going to be my last try. So we'll just make it big. Okay, so I've got my perpendicular segment that I'm sure that you guys have all created so beautifully. This is point X, this is C, and this will be D. Take out your protractor, and you're going to find the measurement of each of these angles, and then you're going to use the ruler part of it to find the length of each segment. So as we're going through here, what we find out with the measure of AXD is that it should be a 90-degree angle. AXC would also be a 90-degree angle, and BXD would also be 90-degree angle, and BXC also 90-degree angle. Now when you take out your ruler and you measure all of these, your measurements might be different than mine. Basically what I'm hoping you're seeing is things are either congruent to each other, or they're half the length or twice the length. So case in point, you look at segment AB, you measure that. When you measure segment AX, it should be half the measurement of whatever AB is. And same thing for BX. And those AX and BX should be the same. Kind of go all the way through there, pause the video, and then come back to number 3, and let's go ahead and answer these questions. The angle formed by the line of intersection of segment AB and CD is 90 degrees. The perpendicular bisector CD is going to divide AB into 2 congruent parts. Part 4 wants us to add some more points in there. So I'm going to go ahead and add those points in there. Add 3 points labeled Q, R, I'll put S right here. It doesn't matter, just as long as they are on that perpendicular bisector. Now on the following page, I'll read you the instructions, and you can go ahead and do what it's asking you to. It says, using a ruler, measure the length of each line segment. So there's no line segment there for QA, so you're going to have to use your straight edge to create a line from Q to A, or A to Q, the way I drew it, and then the same thing from Q to B. You should find that those 2 lengths are the same. Next, we're going to do one from R to A. R to B. Use your ruler and measure that. Those 2 red lines should equal each other in length. S to A, S to B, those two purple lines should also equal each other. What do you think would happen if you drew a line from A to C and B to C? What do you think the relationship would be between those two lines? If you said that they were congruent, you would be correct. So we're going to use that information to write a conjecture. It says write a conjecture about the endpoints of a line segment and any point on the perpendicular bisector. So anywhere there's a point on the perpendicular bisector, I'm going to use this just as an illustration. Don't write on your book yet. Anywhere that there's a point over here, I can make the assumption that if I were to draw a line from endpoint to endpoint, it's going to be equal to each other. To endpoint to endpoint, endpoint to endpoint, those are going to be equal to each other. So the distance will be the same to each endpoint. On the next one, grab either a sheet of patty paper or just kind of follow along as we're going through this. If you have the patty paper, I want you to copy segment AB and its perpendicular bisector of CD. Then on the patty paper, draw a line from A to D, and then another one from B to D. Make a conjecture about the two triangles ADE. So ADE, this triangle here, and this triangle over here. Well, what you just drew, you learned on the previous question that any point along that perpendicular bisector is the same distance to each endpoint. You also learned that a perpendicular bisector creates 90-degree angles. So what can you tell me about those two triangles, triangle ADE and triangle BDE? Well, what kind of triangles are they? They are both right triangles. And based on the previous question, we know that AD is congruent to BD. So if you have right angles, then you have a right triangle. Now, with your patty paper, or paying attention to me, with your patty paper, if you were to take this line of this perpendicular bisector, think of it as a line of reflection, and reflect, fold your patty paper to where A maps on top of B. You're going to see that those two triangles match up. So not only are they both right triangles, but they are also congruent to each other. And the original triangle is an isosceles triangle. Okay, so if I look at the triangle ADB, it has two congruent sides. So an isosceles triangle contains at least two equal length sides and two equal interior angle measures. So we have the perpendicular angle right here, the 90-degree angle. Also, when you folded them on top of each other, this angle right here, which is DAE, mapped on top of triangle DBE. They were congruent to each other. So, in triangle ABD, angle DAB is congruent to angle DBA because a reflection is a rigid motion that preserves angle measure. Okay, so when you reflected over that line of reflection, your two angles were congruent to each other. Since angle DAB is congruent to angle DBA, and our two sides, AD is congruent to BD, then by definition, triangle ABD is an isosceles triangle. All right, so hopefully the people that were in class today, they are joining me here. We're going to kind of bring it all together. If a point is on the perpendicular bisector of a line segment, then it is equidistant from the endpoints of the line segment. In the diagram over here, YX or XY is the perpendicular bisector of segment AB. Let me go ahead and mark some of this stuff up so I know that I've got right angles all the way around. I'm not going to mark them below. I also know that AK is going to be congruent to BK. I know that XA is 7.7 millimeters. YB is 6.85 millimeters. And segment AB is 7.7 millimeters. So I'm going to go ahead and divide that by 2. 6.85 divided by 2 is 3.85. All right, number 1 says label all segment measurements from the given information on the image. Okay, let's do that. Okay, we've done that. Then label all the other segments based on the relationship of a line sector and its perpendicular bisector. Okay, so think about the patty paper. If you were to fold this along segment YX, then AX is going to map on top of BX. So BX is also 7.7 millimeters. Conversely, we have BY is 6.85, so BY is 6.85 millimeters. Then AY is also 6.85 millimeters. Number 2 says, given that XY is the perpendicular bisector of AB, label all of the congruent angles. Okay, so when we folded it along the perpendicular bisector, I would know that, trying to find some good colors here that I haven't used, this angle here, when I fold it over, is going to map on top of this angle here. So those two are congruent to each other. Down at the bottom, BYK, this angle would be congruent to AYK. So those two angles are congruent to each other. Also, when I mapped over, I would find that XAK, this angle right here, would be congruent to XBK. And the fourth set of congruent angles would be YAK, 1, 2, 3, 4, would be congruent to YBK. Okay, if that's not crystal clear, take out some patty paper and trace over it, fold it, and see if you don't see all the congruent angles and the congruent lines. The triangle formed by a line segment and two segments drawn from the endpoints of the segment to a point on the perpendicular bisector of a segment is an isosceles triangle. Okay, so the top half of that is an isosceles triangle. The bottom half of that is an isosceles triangle. All right, so now for the math part. We always do a little bit of construction, and then we do a little bit of math. All right, so we have to figure out what is the value of x. So what I learned a few moments ago, that is if we have a perpendicular bisector, I know that I have a 90-degree angle. I know that these two are congruent to each other. These two are congruent to each other. So let's mark everything up. KD is negative x minus 1. PD is negative x over 2. So it makes some people happier just to do negative 1/2 x plus 19. Okay. What is the value of x? Well, to find x, we set those two expressions equal to each other. So negative x minus 1 equals negative 1/2 x plus 19. Okay. Remember how to solve these at this point. You need to get rid of your smallest variable term, and then you have your two-step equation. So my smallest variable term is negative 1x. So I'll add 1x to each side. And then I can solve my two-step equation. Subtract 19 on each side, and then divide by 1/2, and I get a negative 40. It's okay for x to be negative. What's not okay is for length to be negative. So it says, what is the length of KD? So let's make sure that our answer does not come out negative. We would have negative x, which x is negative 40, minus 1. So that works out perfectly because minus a negative is positive. So 40 minus 1, our length is 39 units. Okay, your turn to figure out this one over here. We have UT is 8y minus 12. ST is 3y plus 23. And you just solve it the same way. We know that those two are equal to each other, so 8y minus 12 is equal to 3y plus 23. So I get 5y Sorry, I'm trying to do something in my head and it wasn't working. Goodness gracious, give me just a moment. Okay, I have 5y minus 12 equals 23. There we go. Add 12 to each side, and I will get 5y is equal to 35. So therefore, y is equal to 7. I'm going to stop it right there. Thank you for joining me. Thank you for watching the end of the lesson. And I'll see